Friends of Chemistry, greetings. We're doing practice problem number 2 in module 13. Please read it, Martin.
Benzene, C6H6, is a toxic liquid with a delta H subscript F degree. How do you say that?
An enthalpy of formation.
Oh, right. An enthalpy of formation of 49.00 kilojoules per mole. The best method for disposing of benzene is to burn it in the presence of excess oxygen. What is the delta H degree for this reaction? You should know all of the phases in this problem, so use Hess's law.
So this is actually the standard enthalpy of formation with this degree symbol. Okay?
Yeah.
All right. So we should know all the phases. So this is liquid, right? If we burn in the presence of oxygen, what's that? O2, right? What are we going to get?
2SO3.
What?
Oh, no. Then we'll get carbon dioxide and water.
Right. What phase will the oxygen see here? Gas.
Gas, yeah.
We're told the benzene is liquid. What will the
Everything
carbon
else is gas.
Okay, so we are told to use Hess's law. Okay, now Hess's law is defined with words on page 429, where it says enthalpy is a state function and is therefore independent of path. And then on page 431 in equation 13.9, we're told that this equation, the standard enthalpy of formation equals the summation of the standard enthalpy of, the standard change in enthalpy equals the summation of the standard
enthalpy.
Where am I? All right, the standard change in enthalpy
equals
the summation of the, I'm losing it, is the standard enthalpy of formation of the products minus the summation of the standard enthalpy of formation of the reactants. Okay? Yeah. So let me write that out. What is this again? Delta H degrees is the standard change in enthalpy. If they only say standard change in enthalpy, they'll expect you to know what that is. And it's equal to the summation of the standard enthalpy of formation of the products minus the summation of the standard enthalpy of formation of the reactants, right?
Yeah.
Okay, so we do not yet have a balanced combustion equation. So the first thing we're going to have to do is figure that out. So let's say here we got C6. Let's make this 6. That makes this 12. And this has to come even. So we make this is supposed to be 3. Nope, it can't be 3 because that's odd. So let's make it 6, right? That gives us
6 looks good.
12 of these and 6 of those. So now if we have 12 of these, we need 2 of these, which gives us 12 of these, right? Now we have 12 of these, 12 of these. We have 12 of these, 12 of these. And here we have 6 and 24. So we need 30, 15. Is that right? How does that look to you?
Yeah, looks good.
All right. Okay, so What do we know about the standard enthalpy of formation of oxygen? What's the standard enthalpy of formation of any substance in its elemental form? So oxygen in its gas phase is 0. So this here is 0. You know the line through it so you know it's not oxygen, it's 0.
Yeah.
Okay. We are told that the standard enthalpy of formation of this
Benzene
is benzene is 49.00 kilojoules per mole. So what's the summation of the standard enthalpy of formation of the products? It's going to be this because this is 0, right? So 49.00 kilojoules per mole, right?
Yeah.
And how many moles do we have of that?
I think it says over there. I think it says on the board.
Yeah, there's 2 of them.
Yeah.
Okay, so that's what we've got over here for the, and these are the reactants, of course, right? So that goes over here. So we have 2 moles per 49.00 kilojoules per mole. Moles, what's that? 98, right?
Yeah.
98.00 kilojoules. How about the product? Here we can use the table, which we find on page 431, of the standard enthalpies of formation of a variety of substances. So let us locate carbon dioxide in its gas form. What's the standard enthalpy of formation of that?
Negative 394
kilojoules per mole. And we've got 12 moles of that, right? How about water in its gas form?
Negative 242 kilojoules per mole.
Okay, so we have to sum those, okay? So negative 394 times 12 is negative 4,728, and then 242 times 6. Negative 6,180. Is that what you get as well? I'm summing the products. I have to do a summation of the products.
I got negative 6,278.
Well, you didn't stop where I did. I'm not done.
Oh, okay.
I have I'm setting up my equation here.
Oh.
So first I'm making a summation of the products. So what's that? What's the summation of the products? It's this.
Yeah.
Right?
It's that.
So we have negative 6,180 kilojoules minus 98.00 kilojoules, right?
Yeah.
And what do you get with that?
Negative 6,278 kilojoules.
Okay. Most excellent. So there's all the math and the formula we were using.
Yeah.
And how we got it. Good work. Thank you for joining us. Ask any questions in the comments below.